Hello guys, in this video let's talk about how to make the control surfaces of an aircraft. For this video I'm gonna use the vertical stabilizer and rudder assembly to show you how to make the control surface. And the reason why I'm using this particular control surface here is because it is the simplest, as it doesn't follow any complicated profile since it's a vertical profile. And that's pretty much it. And all the other control surfaces, like on the wing or on the elevator or anywhere else on the aircraft, can be made by the same method that we use here. Usually the problem with making control surfaces is that we won't be able to get a perfectly lined up seam at the point where the rudder or where the control surface actually meet the parent surface of the aircraft. So as you can see here, the seam throughout the control surface is almost perfect. It is not changing, or it is not having big gaps or anything in between there. And also, as you can see, when I move the control surface, the seam pretty much stays the same. So let's see how we can make this. So I have already made the vertical stab over here, and before you do anything to this part, make sure that you make another copy of this vertical stab, the exact copy of this part. So I made an exact copy and I named it rudder, and this is what I've opened in the SolidWorks engine right now. So the first thing that we have to do is we have to sketch out the portion that we have to cut out of this vertical stab. For that, I have taken a picture of the A380 as a reference. So as you can see, the rudder itself is divided into two parts, but we're not going to do that. We're just going to make the rudder as a single part itself. So the profile comes from here, it goes straight down, but it does not go to the fuselage itself. It stops right kind of like 2 feet away from the fuselage, or 1 feet, I'm not sure, and it makes an angle as it goes down and meets the fuselage. And make sure note the other thing here, the angle that this line and this line makes is 90 degrees. That means we can say that this line over here or somewhere in there is the pivot point. So we're gonna do that right now. So we are gonna sketch an image over here for us to make as a reference for cutting the rudder off. And there you go. I have already sketched out the part that we have to cut, and we can see that I have sketched out I have made a sketch for throughout the entire part, and also a sketch that kind of shows us where the rudder is going to be. So this portion is going to be the rudder, and this is going to be the vertical stab. And make sure you draw both these sections in this one sketch itself, because we will need it for the other part too. So, and before you do any cutting or anything, let's do a small thing here. So remember the thing that I talked about the seam gap being even throughout the rudder, and that is because I made a small gap over here when I made the cut. And since the rudder's thickness or the vertical stab's thickness increase as we go down from the top, we have to make the clearance from there to here in an increasing manner. So there should be a gradient as we go down. So this is kind of like a trial and error method. So what I did is I made a small line over here that is about 25 millimeters long, and also a line here which is collinear or parallel to this line, and that line is about 100 millimeters long. And then I used this to connect this point and continue that line to here. So now we can make this a construction line, and there you go. So we have two lines here, the line for the gradient and this line as the pivot point, and make sure that this line, the pivot line, is always perpendicular to this line. So when the rudder rotates, it's not gonna make an angle with this this whole vertical stab section. So now we're gonna use the gradient line to cut off the rudder from the vertical stab section. So to do that, we just have to make this the construction line, and then we are good to go. Also, you can see that I made a small line here that is coinciding with the point on the very far end of the vertical stab. That is just for reference, so that when you copy this same sketch to the other file, we won't be misaligned. So let's see what's gonna happen. So I'm just gonna cut it out, and I want this section to be cut out. So I'm just clicking that, and then through a bolt. Okay, there we go. So the entire rudder portion that we are gonna fix into the vertical stab is cut off. Let's hide this sketch. Now what we have to do is we have to make a pivot point there. Remember, we made a 100mm gap from this line to the pivot point, which was somewhere over there. If you take this sketch, so you can see that the pivot point is here, which is not falling on this line here, but we use this section, this line, for cutting off the rudder. So we are going to make the pivot point on this point, and before that we should make a semicircular cut loft inside this part, so that when the rudder is fixed in there, it kind of fits in nicely and evenly without any interferences. So at first let's make that lofted cut. So for that, I'm going to start a sketch on this plane. So I have already made the two profiles here at the bottom and at the top on this plane, and now I have to make two guide curves. So you cannot use any plane like the right plane for the guide curves, because this point and this point are in two different planes. So the lines that connect these 2 points are going to be a 3D sketch. So I'm just going to use the 3D sketch here, the line function, and I'm just simply going to connect those 2 points with the sketch tool here. So that point and this point over there we go. We have the first guide curve. I'm going to do that on the other side too. And there we go. We have the second guide curve ready. Now we can do the lofted cut. So features, lofted cut, select the two profiles. Oops. The two profiles, the guide curves, and there you go. The loft is cut out, and now we have to make a pivot point. So remember, we agreed on using this point over here because this is the pivot line. So we're gonna make a small circular boss there. Sketch, say 20mm. So it's better you cut out a quadrant before you do the boss base. This is not the way you do it in the real world. This is just to show how this is just for show. This has nothing to do with engineering. So I'll show you why I do that. So cut a quadrant there, and then we're gonna extrude it. So say 50 millimeters. There we go. And that's all that we have to do on the vertical stab. So save it and we can close it. So before we close it, copy that. So we have that copied and close it. Now open the rudder file. So here we are gonna do the same thing, but we are gonna cut out the second portion, not the portion that we already cut out in the vertical stab file. We're gonna cut out the rest of the area. So we're gonna make a sketch on the right plane, and we have already copied the image, so paste it here, and we already agreed that this point is going to be the reference point, and that is gonna line up with this point over here, this very end. So we're going to use the convert entities to identify that line. So we have that point there. Now control, oops, I just missed it. So convert entities, control A, unselect that, and move entities, select this point here, and make it coincide with this very end. There we go. We have everything perfectly lined up. And okay, so here in the previous file we used this line for cutting, but in this file we're going to use the pivot line itself for cutting, and I'll show you what's going to happen there. So we're going to convert this into a not from construction line into a solid line, and we're gonna convert all the other lines into a construction line. So this is a construction line now, and this one too. There we go, everything is all done. Now we can just use the cut function to cut it out. So earlier we used this profile to cut out everything, and now we're going to use this one because we don't need this anymore. We need this section here, so we're going to cut out this. Roll both, and there we go. So we have the rudder section that is ready, but again we have to do a little bit of construction or lofting over here. So remember we made a lofted cut on the very end side of the cut on the vertical stab. So here we are going to do the opposite of that. We are going to make a loft on this very plane over here. So let's start with the sketches. So we have all the sketches and profiles and guide curves, everything ready here. The guide curves again are a 3D sketch, it's not a 2D sketch. So now we're just going to loft it. There you go. The loft is ready, and now we have to make the pivot that is on the bottom here. So when we made the pivot on the vertical stab, remember we made a 100 millimeter clearance from the face of the cut. But here, since we made the cut on that pivot point, we are going to use that as the reference. We are going to use that very point where we finish the cut as the line where we're going to use the pivot point. So we know that this whole profile here, this whole edge that you see here, is the loft. So the sketch was ended, or the part was cut from this point to this point over here. So that's where our pivot is going to be. That line is where the pivot point is going to be. So the middle of this line, again 20 millimeters. And remember we made a quadrant. Just gonna cut it and then make the quadrant over that. So extrude cut, go in 50, and then on another sketch here we are gonna make the quadrant. So the quadrant is here, and trim the other out. Oops, cut, extrude. We don't need 50, like 20 would do. And there you go, that is done. So the rudder and the vertical stab are done. So now let's assemble it. For that, open an assembly, browse. So we have rudder, and we have the vertical stab. So I'm gonna fix this vertical stab first. So that is fixed, and that is floating. So now we have to line up these two pivot points. So we have to mate that cylindrical surface to the cylindrical surface that we created on the rudder. It's going to be a concentric mate, so that it is perfectly lined up. And now we know that the rudder doesn't go like this on an aircraft. It always stops at a particular angle. So say let's put an angle constraint of 30 degrees to one side and 30 degrees to the other side. So to do that, we are going to make use of the quadrants that we cut out. So we're going to reference this plane over there, or that surface over there, and that surface over there for the constraints. So again, take mate, so that surface on this rudder portion is already selected, and we're gonna use that surface on the vertical stab. So instead of going to standard mates, we're gonna use advanced mates and put an angle constraint over there. So the maximum angle that it should go would be in this direction, and let's say it is 30 degrees. So the maximum angle that it can go is 30 degrees, and the minimum angle is going to be in the negative side, because when these two planes are in the same plane, it is a 0 degree, and by the time it moves to this side, it is going to be positive, and by the time it goes to this side, it is going to be negative. So we're going to put the minimum as negative 30 here. So we have the constraints there. Let's give that the constraints. There you go, it is stopping there and it's stopping there. So the constraints are working. Now we have to bring that part down onto the vertical stab. So for that, we're gonna select the mate and this face and this face, coincident, and there you go. The mate is done and it is complete. The rudder and vertical stab assembly is complete. So there you go, the constraints are working. So it is not going to go 30 degrees farther than 30 degrees on either side of the vertical stab. So this is purely dependent on the aircraft. So I don't know what is the angle for any aircraft. Maybe if you do some research, you can find it online. So this is basically the way how we do the control surfaces on any aircraft control surface. This can be done on the aileron too. The only problem is that the aileron is having a curved profile, or a little bit 3D curved profile. So you might want to be careful when you do the pivot, when you find the pivot line. And make sure that the pivot line is always perpendicular to the line that we cut on the wing or on the surface, because otherwise we won't get a perfect lineup. So as you can see here, since the pivot line is perpendicular, even though I move it left and right, it is going to line up perfectly with this base. But if you look at the top, it is not perpendicular, so it is going up and down as I move it from side to side. It's going up and perfectly straight, then up again. So, but that doesn't matter as long as anything is not touching on the control surface. It doesn't matter, that is perfectly fine. So that is how you make any control surface on an aircraft. I hope you enjoyed this video. Please do subscribe for my channel for more videos. Please like my videos, comment on them, let me know what you feel about my videos. Like, I enjoy doing this. I hope you enjoy doing this as well. And thank you for watching again. Please do subscribe. See you later, guys.